Hello everyone, welcome you all to the next session on polynomials of class 10 mathematics. In this session, we are going to learn about division algorithm for polynomials. Before we learn about division algorithm for polynomials, let's recall what is the division algorithm for numbers. Now, when you divide any number by some other number, you have the different statements says dividend, divisor, quotient and remainder. I hope there need not be any explanation for all this. The division algorithm says any dividend can be written as the product of divisor and quotient plus its remainder. So this we have already learnt it in our 9th standard, so I'm not getting much into this one now. So with this, we'll try to relate what is the division algorithm for polynomials. Here, instead of numbers, we are going to talk about polynomials. So you have one polynomial divided by another polynomial. So let's take the polynomial p of x is divided by another polynomial g of x. Of course, the polynomial g of x, that is the one that is going to be divided by, or that is a divisor, should not be equal to 0 always. So if at all you have a polynomial p of x which is divided by a non-zero polynomial g of x, then as per the previous statement, we can still write the polynomial p of x as the product of g of x and q of x, which is nothing but the quotient, and plus your r of x. R of x is nothing but your remainder. So let's get much into this after we see how to divide any two polynomials, because the entire division algorithm depends upon dividing two polynomials. Let's learn how to divide two polynomials and then we'll come back for the further discussion on division algorithm for polynomials. So we are going to learn how to divide two polynomials. Now here is an example for you. Divide 2x square plus 3x plus 1 by x plus 2. Now you can see the given polynomial. So this I can consider it as p of x. That is the polynomial that has to be divided. Let me mark it as p of x and I'll mark this as g of x. Now you can see your p of x is a quadratic polynomial and g of x is a linear polynomial. So let's divide this given polynomial and we'll discuss more on this. Now as we normally go for the long division, we'll put the polynomials under the lines here. So we have the quadratic polynomial, that is p of x, inside the lines, and we have the linear polynomial outside the lines here. Now let's start dividing the polynomials. Now how do we start with? We have a quadratic polynomial which has 2x square plus 3x plus 1. So to start with, the first step for division of any polynomials is take the first term of your dividend. Here the first term of the dividend is 2x square. Now divide this term by the first term of the divisor. Here the first term of the divisor is x. Now divide one by the other. So divide this 2x square by x. This gives you 2x. You can even use your law of exponents or the cancellation law, anything. You can get an answer called 2x. So when you divide the first term of the divisor by the first term, when you divide the first term of the dividend by the first term of the divisor, the number what you get will be the first term of your quotient. Here it is. You have 2x written on the top of the line. We have written it above the line where we are going to show the division. Now 2x is written here. There is nothing but your quotient that you get it after dividing 2x square by x. Now let's multiply this 2x by x plus 2. It's not a new process. This is similar to what we do when we divide two numbers. Let me take a number as an example here for which you'll be able to understand here. Let me take a number say 467 and let me divide that by 5. So the first step that what we do is we look at the first number here that will be smaller than 5. So we have 46. We'll be considering the two-digit number. When we have this two-digit number, we will say 9 and then we will write 45. Now we write this 45 because we multiply this 9 and 5. The same way we are going to do it here. I am going to multiply this 2x by the entire expression x plus 2. Now you can check 2x into x gives you 2x square. Hope you'll be able to understand. 2x with the x gives you 2x square, and you have a plus sign here, so you add a plus sign here. Then 2x into 2 gives you 4x. The second term is also done. So 2x multiplied by x plus 2 gives you 2x square plus 4x. Now after this multiplication, what do we do here? Now what we are doing here is actually subtraction. So we subtract 45 from 46, leaving the remainder 1. The same thing we are going to do it here. But when it comes as an expression, we have to subtract the expression from another expression. Now it is like 2x square plus 3x plus 1 minus of all this. You can see 2x square plus 3x plus 1 minus of 2x square plus 4x. Now it's not possible for us to write like this every time and then do the subtraction. So what we do here is we'll just change the sign of the terms which you have it in the product. That is where there is no sign, this means it is positive. So we have 2x square with a plus sign, so I'm just writing it with a negative here. And we have 4x with a positive sign, so this also I'm going to write it with 4x. The reason why I'm changing the sign here is you can see from here, when I subtract this, I'll have it like 2x square plus 3x plus 1 minus 2x square minus 4x. Now you can see plus 2x square has become minus 2x square and plus 4x have become minus 4x. So this is the one which we are making it a short way of doing subtraction. So just change the signs of the terms in your product. So the product here is 2x square plus 4x. Since both are positive, I am going to change the sign to negative. So now you consider the numbers like the terms like 2x square minus 2x. Now 2x square minus 2x gives you 0. And then 3x minus 4x gives you minus x. So this part is done and you have 1 left out here. So that one has been brought down here. So when you divide the given polynomial, that is 2x square plus 3x plus 1 by x plus 2. We have the quotient 2x and we have the remainder minus x plus 1. Now, can we stop here? Let us see whether we can stop here or not. You can see the remainder what you have got now is a linear polynomial and your divisor is also a linear polynomial. So when the degrees are same, you can still proceed with your long division. So let's continue the long division like this here. Now you have minus x plus 1 as your divisor. As your dividend. So forget about your 2x square plus 3x plus 1. Consider minus x plus 1 as your dividend. Now when minus x plus 1 is your dividend and x plus 2 is your divisor, the procedure is going to be same what we have done in the previous step. That is, consider the first term of the divisor and also dividend. Now the first term of the dividend is minus x and the first term of the divisor is x. Let's divide one by the other, that gives us minus 1. Now you can see this minus 1 is the one that has been written here. So we already had 2x in the previous step. Now I am adding minus 1 to it. So the quotient becomes 2x minus 1. Let's proceed here. We have already multiplied x plus 2 with the 2x. So I am not going to do anything with this 2x now. So the left out is minus 1. So let me take this minus 1 and multiply this minus 1 with the polynomial x plus 2. So minus 1 into x gives me minus x. You can see it here. And then minus 1 into plus 2 gives you minus 2. So when you multiply minus 1 with x plus 2, you get minus x minus 2, and that is what written here, minus x minus 2. And we are done with the multiplication. Now the next step is subtraction. Now when we subtract, the procedure what we looked into the previous step is we'll be changing the signs of the product. the product here is minus x minus 2. Since we have minus sign here, that will be changed to plus, and again the 2 is also with a negative sign, so that will also be changed to plus. So now the expressions are like minus x and plus x. Minus x and plus x gives you 0, and 1 plus 2 gives you plus 3. So 0 plus 3 is actually 3. Now the question again says, can we stop here or do we have to continue further? Now this depends upon your divisor. Now we can see the divisor is a linear polynomial, and your remainder that you've got now is a constant polynomial. The degree of this linear polynomial is 1, and the degree of this remainder is 0. So when the degrees are less than this, you cannot proceed with your division here. That is, your remainder should always have degree either equal to or more than your divisor. You can see the degree of remainder is less than your divisor now. This is 1 and this is 0. So you cannot continue with your long division, and hence you stop your division procedure here. So this tells you that your quotient, when you divide your quadratic polynomial 2x square plus 3x plus 1 by x plus 2, you get 2x minus 1 as your quotient, that is denoted by q of x, and 3 as your remainder, which is denoted by r of x. Now, as per the division algorithm, let us see how are we going to write it here. So we know if a polynomial p of x is divided by a polynomial g of x, the quotient, you can write it as p of x can be written as g of x into q of x plus r of x, which is what we are going to write it for the given example. That is, 2x square plus 3x plus 1 can be written as x plus 2 into 2x minus 1 plus 3. You can very well see this is your p of x and this is your g of x, this is your q of x and this is your r of x. So we have understood how to divide two polynomials and what are the conditions that you can have when you divide it, and when are you going to continue your process, when you have to stop your division, everything we have learnt it. Now let's understand the division algorithm for polynomials clearly. Here is the definition of division algorithm for polynomials. If p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x equal to 0 or degree of r of x is less than degree of g of x. So we will be stopping our division only when either r of x is equal to 0 or degree of r of x is less than degree of g of x. You can check it here. We had the degree of r of x here is 0 and here the degree is 1. So degree of r of x is less than your degree of g of x, and this is why we stopped our procedure. Okay. So with this you can clearly, you would have got a better idea about how to divide two polynomials and what to proceed and what not to be done in everything. Now there is one question which will make us to understand one more concept. Now we say that there is a possibility of your r of x to be 0. Now what happens if r of x is equal to 0? That is, when you divide a polynomial by another polynomial, what happens if your remainder is 0? So you can take it as your question to work it out, and let us meet in the next session to have a better understanding. Meanwhile, I would like you all to try with your exercise problems, that is exercise 2.3. You can start trying to divide the polynomials there and understand whether you are able to come up with the procedure, what you are able to follow up the procedure. Now I'll meet you in the next session in working out one more problem on dividing two polynomials so that you can have a better understanding. Until then, keep trying the exercise problems. Thank you.